A very warm good afternoon to everybody. Hope we have a wonderful session. That is the industrial visit. So we are in the day 5 and session 9 of our faculty development program on applied energy engineering from renewable system to sustainable practices. As we move towards the concluding phase of this FDP, today's session highlights one of the most significant concepts driving sustainable development, the circular economy. Traditionally, the construction sector has followed a linear model: take, make, and dispose, leading to enormous consumption of natural resources and generation of waste. A circular economy, however, encourages us to rethink this approach by minimizing waste, maximizing resource efficiency, and transforming construction and demolition waste into valuable and sustainable materials. Today's lecture, Circular Economy in Construction, Turning Waste into Sustainable Resources, will provide valuable insights into innovative waste management strategies, sustainable construction practices, resource recovery, recycling technologies, and the future of environmentally responsible infrastructure. It is my privilege to introduce our esteemed speaker for this session. We are honored to have Hamjala Alam, Assistant Professor of Department of Civil Engineering, Dr. B.C. Engineering College, Durgapur. He has over 12 years of teaching experience and specializes in environmental science and engineering. He is currently pursuing his PhD at ACSR C in Durgapur after completing his MTech from IIT, that is ISM. His academic interests include environmental engineering, geo-environmental engineering, environmental impact assessment, pollution control, and environmental laws and policy. His scholarly contributions include 8 journal publications, 7 conference papers, 5 book chapters, and 3 patents, reflecting his commitment to teaching, research, and sustainable engineering practices. Now I request our respected principal, Dr. Orijit Kumar Banerjee sir, to kindly felicitate our distinguished resource person with a bouquet as a gesture of our gratitude and respect. Sir, please. Thank you, sir. Without taking much of your valuable time, I invite Mr. Hamjala Alam to kindly take over the session and enlighten us on this topic: circular economy in construction, turning waste into sustainable resources. Good afternoon. Thank you so much, for the one of the finest introductions that you have given. And thank you so much, Arjit Banerjee sir, for inviting me. All of you must be very tired after the long journey. And let me express that many of you are maybe more senior than me. So with due respect, this is my first time I am conducting any kind of FDP. I'll commit mistakes. So in advance,
I would like to apologize for any mistake that I will commit. So basically, the title says as the title says, circular economy in construction, turning waste into sustainable resources. So most of the construction sector, unfortunately, in our country in particular, and in most of the other countries, they follow a linear trend. When I say linear trend, that means there is a take, make, use and dispose kind of mechanism. That means the raw materials, it is basically raw materials are taken, they are processed into some product form. So take to make, then use, it is utilized, it may be building, it may be any form of construction, and after that it is disposed. And in the, when I say disposed, that means there is a landfill site in Durgapur, and I think we at BCR get the offensive smell most of the time. Maybe you people also receive the offensive smell sometimes at least, during a heavy rainfall also. So there are many landfill sites, numerous landfill sites, and the volume, the size of the landfill sites are increasing day by day. Because if we unscrupulously take and dump everything in the west side, then definitely the volume, the size of the landfill site will increase. So in the linear economy, basically that take, make, use and dispose approach is there, and in that there is a loss of resources, there is a tremendous pressure on the natural resources, particularly in the very initial stage. Just like any construction begins, suppose we want to manufacture cement, okay, we want to manufacture aggregates. When I say aggregates, the fine aggregates, I think most of you are not from civil engineering background, so most of you are not from civil engineering backgrounds, I think.
I am from civil.
Definitely some of you, I am telling most of you are not from civil engineering background. Some of you must be. So fine aggregate, that means the sand. And coarse aggregates, they are in larger size, okay. So the raw materials that we use in the process of manufacturing of raw materials, just like in the process of manufacturing of sand. So there is a tremendous load on the river banks, okay. Then suppose for cement manufacturing, you know, for every 1 kg of cement that is manufactured, around 1 kg of carbon dioxide is released into atmosphere. Similarly, in the process of building construction, lot of energy is used, and when the building construction has been finished, in the process of providing electricity, lighting, heating, cooling, all the appliances, there also electricity is used, and that electricity comes from the thermal power plants, either coal-based thermal power plants or any other sort of, and most of the power plants in our country, suppose they are of coal-based type. 70%, 80% of the thermal power plants, they utilize coal. And when 1 kg of coal is burned, around 2.4 kg of carbon dioxide is released. Similarly, 1 meter cube of natural gas, if it is utilized, okay, so it releases tentative 1.9 to 2 kg of carbon dioxide into the atmosphere. So that is why we must have witnessed, every one of us must have witnessed climate is changing, okay. There used to be 6 seasons in India once upon a time. We hardly see now 3 seasons, predominantly summer season, then erratic and unpredictable rainy season, and a very short-lived winter season. So that is, at the same time, global warming is increasing. The global warming is what? It is basically the atmospheric gases, just like carbon dioxide, methane, water vapor, etc. They allow sunlight, heat from sun to come to surface of Earth, but they basically resist, they trap the heat and maintain the temperature of Earth. But when there is an enormous quantity of carbon dioxide being generated, enormous quantity of other greenhouse gases that are being produced as a result of burning of fossil fuels and other such anthropogenic activities. So the heat that is being trapped, or heat which is now being trapped, is much more than what it should be in normal sense. So basically, if we adopt this circular economy, then what we will do, we will reduce our dependency on the natural resources, we will reduce our dependency on the fossil fuels, and many of the materials we will discuss subsequently. Many of the materials we will, in this circular approach, we will reuse, we will recover, okay, we will reduce our dependencies, and in this way, basically, circular economy, it's a continuous ongoing process. In the circular economy process, basically every material is utilized till it can be possible. Okay, in the linear approach, in the linear take, make, dispose process, building once constructed or any kind of construction that has been basically built, over a time when its lifespan gets over, it is disposed of, dismantled, demolished and disposed of. But in the circular economy, once a lifetime session is over for a particular kind of structure, a particular kind of building and constructions, then it has to be dismantled and most of the productive things has to be recovered, reused, some of things have to be recycled, and the least possible has to be dumped into the landfill site. And if we do that, then the volume, the tremendous load of the landfill sites and the urgent requirement of more and more area for the landfill sites, it will also reduce subsequently. It's visible, I think, to everyone because I am standing just in front of that is why.
Side of super.
So basically, the need for circular economy somehow I have explained. Around 50% of the world's total globally materials, okay, raw materials, they are utilized in construction sector, and out of that 35% of the waste materials are generated, okay, and those waste materials previously unscrupulously used to be dumped into the landfill sites without any kind of segregation, without any kind of recovery, any kind of recycling and all, okay. But slowly and gradually many improvements took place. Just like 30 years back, the thermal power plants, there used to be a headache on the thermal power plants for disposal of the fly ashes. But later on it was experimented that the fly ashes could be used for replacement of cement. Nowadays I think the standard Indian code also prescribes 25 to 30% of fly ashes, they can be used for replacement of cement. Similarly, fly ash bricks most of us have seen. Nowadays you will see in construction, in flat construction, in building constructions, the normal brick, red bricks are not used. Most of the time fly ash bricks are used. Easy to manufacture, they have strength, and also the fly ash which used to be a burden on the thermal power plant, which was a waste material for the thermal power plant, it has been very successfully utilized as a construction material. In soil stabilization also, in pavements also some amount of fly ash is used. Okay, so basically 35% of the wastage from the construction sector is generated, and around this is around 40% of global energy related CO2 emissions comes from the construction sector. Just imagine, remaining other contribute 60%, but 40% of the global carbon dioxide, it comes from the construction sector, and that is why there is a it's very essential to control the amount of carbon dioxide that is generated from the construction sector. So basically, the economy, circular economy, we will discuss in the subsequent slides. So it can be adopted using these important principles, just like reduce, reuse, recycle, recover, regenerate. You will see frequently 4 R's of construction or 5 capital R's of construction. There are some theories suggest 9 capital R's of construction like that. But by and large, this reduce, reuse, recycle, recover, these are the principal components. So circular economy in construction. So circular economy in construction, it basically focuses on these 4 important aspects. Sustainable design has to be there, a design which can continue for a prolonged duration of time, and when its lifespan is over. You know, everything has got a lifespan, including human beings. It is built for a particular number of years, and then it will not be of any use in after that time. Okay, we say it as service period, or in civil engineering perspective, we say it as design period. After the design period is over, and after its applicability has been done, then if it is sustainable, we can dismantle it. Okay, we can disassemble it, and we can utilize it in some other form. Then waste reduction, which is a very important target in circular economy, because there should be a target to produce minimum waste and to utilize most of the materials in whatever extent possible, where the principle of recover, reuse, recycle, etc. are utilized. Then material recovery, important materials which can be reused, that has to be recovered from dismantling or from when the service period of any construction is over. And then resource reuse. These four important aspects of circular economy is there. And five important principles that are followed in circular economy, that is being described in this picture. So, first important principle is maximum reuse. So, maximizing of the reuse. Basically, in linear construction system, in linear economy, okay, once a product that has been manufactured from the raw materials, that product is disposed of. But here, in circular economy, the maximum utilization of the resources as far as possible for the longest duration, that is the primary target. So maximum reuse. Then design for optimization. That means products should be designed in such a way that they have a huge longevity, huge durability. Okay, and they can be reutilized in future. Then use of standardization, means standard modular materials, if they are used in construction, they can be reused again and again in some way or other. So that requires standardization, which is one of the important principles. Then product as a service. It's a unique concept that suppose in a multi-storied building, if the lift, instead of purchasing it, instead of completely owning it, if we can take it for a lease, okay, or suppose if there are lighting arrangements, if they can be taken at lease from the manufacturer, and they have the right of ownership, and we just take it for lease for a particular number of years, and every service maintenance that will be provided by them, then that is a unique idea proposed in circular economy. So product as a service means that, and minimizing waste and maximizing the reuse. That these are the two very, very important principles to be followed in circular economy. Now, in this slide, the two types of economies have been compared. A more descriptive type of comparison is given in this particular figure. Here, the two types of economies have been compared in this diagram. The left hand side shows the linear economy, which follows a linear pattern. But in circular economy, everything is in a continuous process. From one to another, one thing will contribute to another. You know, nature has provided us, means everything in natural form, it is in circular form. A particular type of natural waste is food for another organism. Okay, it is described in Sanskrit as Jeev Jivasya Bhojanam, means there is a continuous dependency upon each other. So in nature they are in circular form, but in construction it used to be linear form, and by increasing awareness nowadays, in the last I think few decades, a tremendous step has been done towards the circular economy. So in linear economy, basically the resources, they are assembled, okay, from that something is manufactured, any kind of construction, any kind of building, then that is utilized, okay, the construction materials assembled, building elements and macro components are assembled to make buildings and constructions, and after its serviceability is over, it is disposed of, either in the landfill site or there are process of pyrolysis and incineration. You know, a way of getting rid of solid waste is to heat it at a very high temperature. That means disposing of or converting the solid waste on ground into air pollution in air. That is a very easier way to basically convert the solid waste on ground into air pollution or gaseous waste in air. And that is basically, if it is incinerated at a temperature of 800 to 1000 degrees centigrade, everything vaporizes, it converts it into gaseous forms, and it is basically it spreads everywhere, and it hampers the asthmatic patients, the persons with respiratory problems. Even though those persons who are not having any kind of respiratory problems, they might get respiratory problems due to that incineration and pyrolysis, this kind of mechanism. And the remaining things are done in the landfill sites. But in circular economy, what happens? In circular economy, from the very starting stage, from the production stage onwards, if recycled aggregates can be used, if recycled fine aggregates, recycled sand can be utilized, okay. If some sustainable materials can be used which do not harm the atmosphere, just like I told, replacement of certain percentage of cement with fly ash. Cement, 1 kg of cement manufactured, I told previously, it liberates around 1 kg of carbon dioxide. So if we can reduce the manufacturing of cement, and if we can replace cement with some sustainable materials, okay, just like fly ash, just like ground granulated blast furnace slag, okay, and if in future other sustainable materials are searched for replacement of cement. Similarly, some other materials which do not harm the atmosphere, they can be used. So from the very starting stage, production stage, eco-friendly, sustainable, recyclable materials are used in the production stage. Okay. Then they are assembled, okay, and the construction is done. The construction is done in such a way that in future it can be disassembled, dismantled, and utilized in some other forms. We will see one or two examples of that kind of reutilization also in the subsequent slides. Then after the construction is done, it is utilized, and after the service period is over, it can be basically these lines show some of the components can be recycled, some of the components can be reprocessed a little bit, remachining, and again for assemblage, again for remanufacture of something, it can be utilized. Some of them can be re-employed and reused in its natural form. Some of them can be changed and then utilized. Some of them can be recycled, just like plastics. Plastics, they are also used in road materials. Along with bitumen, they are basically mixed, and it increases the quality and properties of bitumen. Similarly, some of the plastics, some of the glasses, etc., they can be recycled. Papers, they can be recycled. There are many materials which can be reshaped a little bit, okay, remachining, and then the utilization of that can be done. So in this way, there is a continuous circulation of material, and that is why the economy is referred to as circular, one to another, just like a continuous circular process. Means the basic fundamental is to utilize the material as long as it can be, okay, and in the linear, just once and for all material has been used, something is manufactured, its service period is over, just disposed of. So that is why it is referred to as linear, and here the continuous circulation makes it a circular economy. So this we have discussed previously that 50% of the global raw materials, they are utilized in construction. Out of that, 35% to 40% of waste materials are liberated, and 40% around of carbon dioxide is contributed from the construction sector, and that is why there is a great concern for controlling of that carbon dioxide. In the core principles of circularity, somehow we have discussed previously also material recovery, then smarter use of materials, reuse, recover, reduce, recycle. These are the important components, important capital R's which are part of the circular economy. Then sustainable material innovations. So here some examples have been given, just like in normal concrete manufacture, okay, where cement, sand, post aggregate, water are blended in a fixed proportion. Concrete is made, okay, the pillars, the beams, the slabs, they are all concrete, okay. So basically in that process carbon dioxide is liberated when cement is basically manufactured, cement is used. So if we can replace cement with some sustainable material, okay, then there are certain concretes which can be made in such a way that they help in carbon sequestration. The carbon sequestration means the trapping of basically carbon dioxide. Generally concrete contribute to carbon dioxide, but if we can change the components of the concrete so that instead of contributing to further carbon dioxide, if they start trapping carbon dioxide, okay, that will be carbon sequestration or negative carbon concrete, okay. So that is carbon negative concrete, which is very much required in sustainable economy. Then bio-based composites, some agricultural and natural fibers can be used for insulation purpose, for some kind of structural designs. And self-filling concrete self-filling materials can be manufactured where some bacteria, okay, they are infused so that if there is a damage to the structure, okay, if somehow water, air enters into the structure, the bacteria gets activated and they react to produce limestone and that damage can be recovered itself. Self-filling concrete. So that will be an important component in circular economy. Then demolition waste recycling process. The demolition waste, which are popularly known as C&D, construction and demolition debris. Previously, the construction and demolition means if any structure that has lost its serviceability, it used to be dismantled, destroyed, and all the debris they used to be dumped into the landfill sites. But later on, some segregation started taking place. You know, many of the construction and demolition debris, they can be reused as fine aggregates, as coarse aggregates. They can be used in soil stabilization. They can be used in several other forms. Okay. So that requires sorting of materials, separating out of materials usable items from the construction and demolition debris, so that ultimately when anything is in that form which cannot be utilized, that should be dumped in the landfill site. Instead of dumping everything into the landfill site and increasing or just enhancing the volume of landfill site, just sorting out and utilizing the maximum material so that the huge load of the landfill site can be reduced. So sorting of the materials, and nowadays automation, large scale automation is utilized for automatically, mechanically segregating the components of the construction and demolition debris. Then crushing of the larger size particles, larger size aggregates to make final aggregates so that it can be reutilized from the construction debris. Just imagine the entire building dismantled, entire building demolished, and the components being reutilized in some way or other. Then purification, if it needs some kind of purification, if the material has to be utilized somewhere and it requires certain kind of purification that has to be given, if certain kind of segregation, certain kind of screening has to be done, that has to be given so that the material can be reutilized. And then reusing new construction. Then bio-waste and mycelium materials. These myceliums are obtained from fungi. Okay, so they can be very helpful in construction. The mycelium can be grown into molds to create biodegradable bricks and insulations. There are several kinds of small scale constructions done using the myceliums, okay, which are obtained from fungi, and they are used for making biodegradable, environment friendly, sustainable bricks, and use of that bricks can be done in small scale construction. So what will be the benefits? The benefits will be, they will be utilizing low energy, they will be excellent in their performance and maintenance, repair and maintenance will be very easier, and when their serviceability is over, then they can be very easily they are fully compostable. They can be used. They can be utilized as compost. Compost is basically use of biomaterials, okay, agricultural materials or biomaterials for plantation and all, turning it into manure so that they can be used as compost.
What would be the lifetime of that biodegradable bricks?
Lifetime of that biodegradable
Bricks.
Normal bricks last a little bit longer. They will be, but with respect to normal bricks, maybe suppose normal bricks last for, if they are properly maintained, normal bricks last for 10 years, they will last for say 5 years, 6 years like that, if they are taken care of properly. But they will not take that amount of load. Huge amount of load has to be avoided. Multi-story building, for that I will show you one example. I have included 2 case studies of a different kind of multi-story building. Here, case study of the wood scraper. The wood scraper is in, this is 12-story twin towers, okay, of 106 apartments in Hamjala Alam district of Wolfsburg, Germany. So here there are 2 towers, okay, 12 stories. They contain 106 apartments, and they are built totally of hybrid timber. Okay, so totally they can be dismantled in future. Suppose after maybe 20 years, suppose it's I read somewhere that for 20 years target they have been constructed. So after 20 years they can be dismantled and they can be reutilized. And this timber hybrid, what is the advantage? You can see here some pros and some cons. Everything has got 2 aspects, pros and cons, some advantages and some disadvantages. The advantages are reduced cost because hybrid timber used, cement, nothing is used, okay, no cement, no concrete. So that is why it is totally built of sustainable material, free of any kind of carbon, free of any kind of greenhouse gas emissions. So this is one of the advantages. Future dismantling, disassemblage is possible, and it can be reutilized in some other way, and material harvesting, fully utilizing the material in its service period. There are certain disadvantages, just like fire safety, the main thing, the primary issue. So it is not that if some fire breaks out and the entire building will get engulfed in that engrossing fire. Okay, so there are automatic alarm systems, automatic circulation of fire, means automatic watering, okay, of fire, and the hybrid timber, what they do, the outer layer will burn, okay, inside there is biochar. It will burn slowly, it will slow down the process so that the necessary steps could be taken to put out the fire, extinguish the fire. Okay, so these are built for 20 years around, and they will take the load, okay, just load off means everything that we keep in our households. These are apartments, so these are meant for dwelling of people, right? So they will take the load of that. Okay. There is one more type of such example I have included, circular retrofit lab. This lab, inside it can be changed thousands of times in some way or other according to the need, the requirement. Okay. So here the circular retrofit lab at Brussels, Belgium. So the circular retrofit lab is sustainable construction project. It serves as a live demonstration of how building sector can be, means from linear to circular economy, how building sector can be utilized. Okay. Here the internal walls and services can be reconfigured time and again without producing any kind of waste material. 70% of the waste the materials that have been used in the building are either recyclable or from recycled materials. 70 to 80% of the components that have been used in the retrofit lab, they are either recyclable or made from recycled materials. And testing on a living lab for circular construction methods. So this is a living example of circular construction done most successfully. The previous 2 examples. the wood scraper building in Germany, and the retrofit lab in Brussels, Germany. Is Brussels, Belgium, sorry, I beg your pardon. Then circular economy in India. What about our country? Has our country taken some steps? So in 2016, construction and demolition waste management rule was passed. Then the focus was shifted towards the proper utilization of construction and demolition debris, okay, instead of dumping it into the landfill sites. But there has to be some policy changes also. I don't know how many of you remember that in, I think 2023 or 24, there were twin towers in Noida, multi-story, 30-story towers, and they were illegal. They were totally built, huge amount of resource, huge amount of money, everything was put in that, and later on it was not bulldozed, it was blasted, okay, and thousands of tons of construction and demolition debris. And then day and night they had to be shifted, the debris had to be shifted, creating further more pollution. First blasting of the 30-story building, twin 30-story building. And it's not that some terrorists are blasting, officially being blasted. So why previously the permission was given? Okay, so there are lapses. You imagine construction of huge amount of 30-story building, then totally dismantling and destroying it officially, and then carrying out the debris. Okay. And I read somewhere in news that the blast powder, after rainfall, the powder was getting dissolved in rainwater and going into the near about surface water bodies and percolating into the ground and affecting the groundwater also. The officers might not agree, but it will definitely harm the human beings residing over that area. So there are policy lapses. So circular economy in that context, use of fly ash in cement, I told 25 to 30% of cement as per BIS code also. We can replace 25 to 30% of cement in construction by fly ashes. Similarly, fly ashes are used in other sectors also, in manufacturing of bricks, in pavements. Then construction and demolition waste recycling plant has been established in Delhi. Then blending of plastic with bitumen. Okay, in that way plastic has been utilized in road construction. Then this GGBS, ground granulated blast furnace slag. This is what in the iron is manufactured in blast furnace. From the iron a byproduct is released, which is a waste for that sector. Okay, from the iron manufacturing sector, that is a waste product. Ground granulated blast furnace slag, but that slag can be used for replacement of cement. So waste product for a particular industry is a byproduct for some other industry. Then eco-friendly cement construction using fly ashes, and this kind of GGBS slags by Ultratech cement has been taken care of. And we in civil engineering department, we have Ultratech, we have a collaboration with them, and they have established a center of excellence in the civil department. You might be knowing. Then role of AI and robotics in these kind of sorting, these kind of construction and demolition debris segregation. Okay, so the AI can be used for detection. Okay, and robotics can be utilized for separation of components. Utilizable things, they can be segregated out and they can be taken care of. Reusable materials can be sorted out, recycling, and those which can be recycled has to be sent later on for recycling. And those valuables which can be recovered and utilized, they have to be recovered and utilized. And then the load on the landfill site will reduce subsequently in that process. Economic drivers means, anything, any kind of construction it is driven by cost and benefit. What is the amount of cost that is being involved and what is the benefit that we are getting. So there are case studies that suggest that profitability has increased. In the process of circular economy, profitability has increased. 23% highest profit margin, high profit margins using the circular economy system. Okay, 1.8 trillion net benefit has been estimated by Alan MacArthur Foundation by 2030, utilizing the circular economy system, and 15% cost reduction. These are the projected data Okay. There are certain challenges also in any kind of work. First is awareness of people, awareness of everyone who are involved in this manufacturing process. So there are high initial costs in the process of circular economy. Lack of awareness among the common people, among the workers, among the builders. Okay, so they have to be sensitized, they have to be made aware of the thing. Means a total involvement of government, industry and academia. Okay, then only the circular economy can be successfully implemented. Then limited recycling infrastructure, limited infrastructure available for recycling process. There are certain design limitations, just like Abhishek was asking that durability. So how can the durability be increased? If the load, okay, the normal construction, it supports a huge amount of load. So will the circular system will support that kind of load? So that has to be taken care of. Policy barriers are there, and material quality means the QA/QC, the quality awareness and quality assurance and quality control means the material should not be substandard. The material should have a particular kind of strength. Okay, so that should be there. The future roadmap. It has been proposed that transitioning globally by 2050 from linear economy to circular economy. So here, maybe we are here and we have to reach this stage. Okay, this is the future roadmap from linear construction to circular economy. And that will have circular design, sustainable materials being utilized and efficient processes being involved. In conclusion, basically we have discussed that circular economy, there will be a utilization of resources and involvement of the materials and resources again and again till the extent possible. Whereas in linear economy, just when the serviceability is over, when we have utilized that building, we have utilized that construction, then it is dismantled and just thrown away in the landfill site. So basically, the reduce, reuse, recycle, recover, these components of the circular economy, they are going to keep the materials and resources in circulation as long as possible. Then, what happened? Oh. Then the blending of the mixing of artificial intelligence, then BIM, building information modeling, okay, digital twins where IoT, Internet of Things sensors are utilized. So these combining with the normal construction process, then they can make the circular economy system much more easier, smarter and user friendly. Future engineers, researchers, policy makers, I told that there should be a collaboration of government, industry and academia to full-fledgedly implement the circular economy. As a conclusion, okay, final thought, that waste is not the end of a material's life. It is the beginning of its next life cycle. So, one kind of structure that has lived its lifetime, okay, then the structure can be dismantled and it can be utilized in some other type of construction. So the end of waste is not the end of that life, okay, it's beginning of new life for construction. So thank you so much.
So the session is open for questionnaire session. If anybody having any question, they can ask our resource person. Okay. So thank you very much. It was a wonderful deliberation. So from this linear model to circular model, I think everyone who is sitting over here, they can use in their life also. I have seen so many times that some of the people, they are using this thing in their life also. Suppose the wash machine that they are used and they are going to waste it, they have used it as a thing, as a basket where they put some plant and grow it. So that can be done, so many things can be done. Suppose you are just throwing out your shoes, which is not useless, maybe that can be used for some other ways. So these are the things that we can do in our life. So thank you very much. Thank you everybody for this session. Now we are having a tea break, and after that a hands-on session.